Many times when we're solving problems using separation of variables, we will have information that will allow us to be able to use definite integrals to solve our problems. And in this case, if we're using definite integrals, we don't have to worry about our constant that we were putting in the last time, that constant c. But our integrals will take a specific form. And let's look at how we could do that using the definitions we had from the previous problem. And we'll say that it starts at x0 and it's going to go to some value x, f(x) dx, and the other side y0 to y g function of y dy. Now, this is kind of a crazy way of writing an integral, and it's actually an improper way to write an integral. Typically, you don't use your variable of integration and mix your limits of integration to the same variable. Unfortunately, Giancoli in his book does this frequently. And so many times I've done it just to be consistent with the problems in his book, so that if you're reading in the book and looking at my presentations, things make sense. But just remember these points, that really these are just dummy variables. In this case, x and y inside the integrand, those are just dummy variables because you're going to insert these limits into your finished integral at the end anyway. And so we don't really have a problem with definition here. We just know that we have to integrate this integrand and then do our standard, put in the top limit, and then subtract by putting in the bottom limit using the theorem of calculus. Now, the better way to write this in a more standard form would be something like this. And so you notice I've just changed the dummy variables from x to u and y to v. These integrals are the same, and if my limits of integration are the same, it is extremely the same. So there's no problem in writing the integrals in either one of these ways, in either one of these formats. They're perfectly equal. And so I leave it up to you how you prefer to write your integrals. Now, the one thing to remember is that xo and yo must, can't spell, sorry, must occur at the same time but may not be in the same may not be at the same location. But they should be related in some way. And also remember that in this case, x and y can be in terms of another variable, or may even be a function. So if we're working with some function with related to time, and I need to make sure that I have time in there in some way, and if xo, our initial x and our initial y, so xo, xo and yo occur at t equals 0, so if xo and yo occur at t equals 0, then our upper limits can be functions of time. And so sometimes you'll see me write integrals like so. And I may have some t0 to t g function of t dt. We are going to see many forms like this semester. And so what you notice is that when I do the integrals, on one side I'm going to have a function that I'm going to solve for, and I'm going to get some function x of t is equal, and then on the other side I'm going to have some integral in terms of t, so I'm going to get some function on this right hand side that's going to be some function of t. So these are different ways to express integrals when solving problems with separation of variables and dealing with limits. There's multiple different ways of putting the integrals, and so it's good to be able to be very flexible in understanding how these integrals are presented and how the problems are being defined based on the format or the appearance of these integrals.